customer requirement, then the compound formulation, compound properties. When the compound properties, then design parameter, manufacturing parameter, simulation, then you get tire properties, then tire performance in the field, and the failure analysis, and customer satisfaction. That means the AI and ML to reduce the number of the trials we take. Now let us consider what is the AI, to apply the AI, what to require. First and foremost, what is required, the historical compound data. That means whatever the data, more number of data, as I told you today, we are using the proof, but tomorrow the data will replace the proof. If you get the millions of data, then what is actually happening, your accuracy or correlation will be much better. So historical compound data is required, more number of data, more accurate, you can predict. Then we require the data cleaning or normalization. Then we require the feature engineering. The feature engineering means what is the PHR ratio, the carbon block surface area, and pure indices, all those things, the pure equivalent. Then we have the type of the model training, means whether the regressions, what type of the software you are considering. Then we have to validation, that is what we considering. When you say that multiple linear regression, we can utilize the model name, or there are they call the robust or interpretable, the random forest things are available, or gradient boostings, or the support vector. These are the certain, these are the IT people. You have to join, work with the IT people, they are aware of it. Then you have to consider the validation, then performance prediction. Now validation is done by the, what we considering, that R square, what we consider for regression equations, and then come performance prediction and optimization. This is the flow chart. That means historical compound data will play a very, very important role, and then the data cleaning normalizations, that will be the guidance of the IT people, can be done. Then you have to, the compounder has to give all the existing formulas, the PHR ratio and other with the property correlations. The next comes about the very clear one certain example I can do here. Of course, today you can see that the material description. Here we have a this is the material description, NR, SBR, carbon black, all those things are giving sulfur accelerator. Plus you have a operational parameter, that means the mixing time, temperatures, or the energy, or the dumping temperatures, and what is the mix time, and so on. So this actually then AI or machine learning model will give the output. Okay, what is the output? We expect that the viscosity, scorch, rheometer properties, tensile property, dynamic mechanical property. Again, this output is come to the reverse prediction. So this will continue, and then we have to find out the algorithm, and ultimately you can predict those things. Let me be very clear. One such example is actually the one case study, small case study here is considering the number of data. Let us consider about we are 170 about we are data generally are giving, and if you give me the data generally this machine operation, they can predict you this around, let us here we have a 30 odd parameters. Since the data is limited, if you consider the spread is quite high. If the data is more, you can narrow down the spread of all these, especially the minimum. These are all geometric data, minimum, maximum, your property, hardness, and all those things you can predict, provided this variation is about plus minus 30%, because the data is very limited. If the data 170, if the data will be later 1700 or 2000 or the close to the 100,000, automatically it will narrow it down to plus minus 2 to 5%. So that means the questions today, AI level, the residual parameters, then you get the compound properties, and here, then again it's back. Then ultimately you have to develop an algorithm, then you can predict this. So this is the preliminary stages. There is people are trying. It may take some of the company already, they have started preliminary in the basic stages, but this should be more prominent next 3 to 5 years down the line. So how the artificial intelligence or machine learning. That means here your raw material data, your the in-process data, and also the performance data. That has to be correlated when you go that back and forth. Then ultimately you can able to predict. Now, these are the certain things. Now I'm just considering about the how important the raw material so far is considering. So in case of the processing, we have a different process in rubber industry. That to not there in a nutshell, because everywhere has to you have to mix the compound, then you have to shape it, the extrusion, calendaring, and building. Then you have to cure it. Whether it is a non-tear and tear in shaping is not there, mixing to curing one can do, and so on. Now let me be very clear. In case of with raw material, these are the process we follow, and the raw material, what is the problem with the cold flow polymer or the receiving area, then the following the system, the FIFO systems, and to restrict the cold certain poly characterize how even the storage of the raw material is important. Then the mixing, you get the generally the mixed quality, dispersion, stickiness, tackiness, and so on. Then extrusion, the iso, extrude appearance, calendaring, blister, release, molding. So these are the problem. But this problem is coupling with something wrong in the compound. That is, the compound is the heart of the rubber industry, and the curing follows. So compound or the mixing ingredients, the role of raw material is very, very important. That I want to explain. If you look in the stage of processing, you have the raw material and the mixing area. What are the problems you get? In the first is the raw material, handling of the dust hazards, materials, aromatic, or oil handling, and so on. This has to be streamlined. Already is done by the mostly the carbon black and fillers, all the pneumatic loading, oil injecting, and all other ingredients, and the polymer bonds are automatic weighing. So loss is minimized. But for the non-tear industry, still is a problem. Then the mixing area, we have several problems. That is dispersion, then the polymer viscosity, the not total breakdown, homogenization, releasing, vast temperatures, and the mixing economy. Then you have extrusion, your flow, shrinkage, tack, and the scorch, blooming, and so on, and the curing problem. So these are the problems why it is happening. That is a very important slide. The compounder also know that how the rate of quality of the economy, the cost and the process you have to consider. The variability is a compound property. Is the polymer filler type processing a variable with the raw material? Then we have a disoil or calendar shrinkage, the density, viscosity, green strength, scorch time, curing characteristics, and tack. This is the compound property depend. Again, what is the equipment? That the clearance, nip gap between the rotor chamber, rotor design, extruder LD ratio, roll configuration, calendar, 3-row or 4-row, the takeoff or let-off system, measurement system, online or offline, and curing method, equipment design. Third is the operating variable, the RPM, time, temperature, pressure, cooling efficiency, utility services, the quality of air, quality of power, quality of water. All this is very, very important for the. This is also the input for the in case of besides the raw material utility service, then the feed volume, feeding system, share rate, share distance, total strain. That means you have to consider the compounding properties, equipment design, and the operating variables. Then you get the quality at a competitive price. So these parameters also influence sometimes the compounding area, because if any of these variables is not proper, you get inconsistency. That is the reason for even the materials is same, machine is same, the operating variables are different, you get a different type of behavior of the compound in the processing. Now similarly, the quality of water, one is the product quality and the type of the equipment. That means, tackiness of the compound or the leaching out of the certain ingredients, the foreign matter depositions and the separation, all those, product quality, related of the quality of water. Similarly, if the quality of water is bad, then scale formation, heat transfer, corrosion, and equipment life. So these are the things rubber industry generally, they don't take that much of this. That is the reason why they got the variability. That means water quality has to be certain specification, what to be the pH, what is the TDS, hardness, what is the cooling water should be, and the boiler fee. These are equally important for making a consistency in the compound area followed by the subsequent process. The quality of water is utmost important in the product quality as well as equipment performance. Otherwise, the most of the thing, residual safety, as I mentioned, it will be different if the scale formation, if it's not the properly cooling the compound, whether in the extruded line or in the calendar line or also in case of the compound. Then you have to make a consequence matrices, the machine parameter, process condition, material properties, and the product properties. There is a correlation. And this consequence mixing in the mixing process is a must, followed by the other processes. Then if you see the ultimate properties, it depends on the product properties depends on the material properties depends on the process condition depends on the machine parameter. Ultimately, the equipment material is the more important to make a consistency beside the people. What we call the man, machine, method, material, measurement, and the environment. 5N and 1E is give it the consistency and the quality. Now then comes up the how manufacturing problem, what comes, how the storage and handling of the material, the raw material contamination, raw material variability and quality, rubber chemical stability that I also talked about, scheduling also plays a very important role, mixing variability, process problem, curing problem, defect in finished product, and the troubleshooting. If you look into these are the certain things in the factory, that the moisture, plastic, metals, steamware, they gives you the raw material contamination. And because this gives you the ultimately problem, especially different types, if the raw materials are the weight, you get a wet polymer, filler, reinforcing material, other ingredients during rainy seasons, then you either reject it or out of avoiding this problem in subsequent process. Plastics or the tags and other polymer bales, liner, or the knots in the the meltable, the river bags. That's also a dispersed material. Metal, polymer, filler, other generally in the these metallic parts, different machine parameters during the maintenance and other. The liner or the rework rubber and all the string where it is available they are using, that is also the polymer. Similarly, if you see the raw material specification, complexity, multiple supply, you get raw material, they have a different customer. So sometimes they have to make the tailor-made specification for the different tire companies or different suppliers. So if you not getting, similarly what is happening, they have a different supplier, but our fabricator, they are getting different materials. So this variability has to be eliminated. If you have a particular plant, particular one supplier, consistency, variability can be reduced. Similarly, suppose if you get the material, there variation of the different properties. Suppose the money viscosity you have upper and lower limit. So you try to get all the target values so that your mixed compounds will behave similarly. Be it a carbon black, be it an accelerator, be it a process oil. All these pieces, the money viscosity or dVp absorption or percentage of MBTS impurity or the polarity, polar non-process of oil. So the question is always try to ask for the target value rather than the upper within the specification or narrow down the limit. Now question is what is the certain rubber chemical who have a stability? Now let us consider the accelerator is a sulfonamide. Generally, as I told you, sulfonamide is a condensation product of the amine and the azoles during storage. They break down with high temperature and the humidity, and they liberate the free amine, and they reduce the spot safety, slower curing, lower modulars in compound. Generally, storageable depending on the sulfonamide, but DCBS may be up to 9 to 1 year. Other sulfonides from the manufacturing days, 3 to 6 months. Similarly, the cases of the insoluble sulfur. Generally, insoluble sulfur, you make it because if the sulfur dosage in certain compounds is higher, especially trading compound or certain wheat compounds or certain area of the sulfur is very high. Generally, partly insoluble or fully insoluble, or especially belt-stream compound with insoluble sulfur, because blooming generally is not desirable for the better addition of the bond. So the insoluble sulfur, which is in percentage insoluble in carbon sulfide, generally insoluble sulfur is reverse insoluble from with the time. It should be proper as the humidity and temperatures to the storage, and it is accelerated by the high temperatures, accelerated in contact with the basic chemicals like sulfonamides and their degradation product. That means sulfur should be put in the same places where putting the accelerator, it should be in the isolated place for the safety as well as the purity quality. Now they reverse soluble if the damping temperature generally 95 to 100 plus minus 5 degrees desirable. Above 110 degrees centigrade, insoluble sulfur becomes soluble and started the bloom. Now the shelf life also, you have to consider the sulfur maximum 1 year in the proper storage. Humidity about 60% and the temperature generally about 23 plus minus 2 degrees centigrade. Similarly, the antioxidants, they are also subject to, because these antioxidants, they are subject to degradation. If it is open box, in an accelerator, it is a accelerator of high temperature, and they are scorching, the gives, and the reduced level of the ozone resistance, and because especially certain antioxidants have got a lower softening point, like a 6-ppb, which we are using still today, is around 50 degrees centigrade to summer there for the lung formation. So the storage of the materials is equally important conditions. Other raw materials, generally all the materials should be identified properly stored, and acidic and basic materials should not be stayed together. Similarly, saturated and unsaturated offer should not be placed side by side. There are different, I'm telling you, the whatever may be the condition is there, how your processing of the problem continued, whether the storage, warm up, or the mill sitting, steam compound, there are the different problem, extrusions. So actually there is if the compound is used, mostly the scorch problem, to be very clear. I don't want to. Similarly, I want to considering what is the problem we are facing in the mixing area. Mixing area, generally the compound, all the performance depends on how the ingredients are properly dispersed and distributed in the matrix itself. Second problem is the scorchiness. You may get a contamination, you get a poor processability or batch-to-batch variation. Now, actually it depends on the 4 factors. One is the mixing procedure, method, workmanship, skill, and equipment is the machine, and the type of the material. Let us consider, if you are getting a dispersion problem or distribution, what is the problem in compounding it? That means either the work input is insufficient, order of ingredients addition is not suited, and not actually order of ingredients, sequence of ingredient additions are equally important. Sometimes the batch size is too large or too small, underfeeding and overfeeding. If you have the wrong rotor speeds, insufficient ramp pressure, excessive wear of the rotors and chambers, especially for silicon mixing. The cold polymer, this applies especially to natural rubber, PDM, or the butyl. Or excessive moisture in the filler, or oils added temperature below the core point. That's the reason oil throughout the seasons generally should be preheated. Whatever may be the preheated, whatever may be 60 to 80 degrees centigrade, any temperature, so throughout the year the flow rate remains constant because viscosity remains constant. Similarly, scorchy compound, generally too high a heat history of the after addition of the curative, the dump temperature too high, or the heat history of the compound residual safety is much less in subsequent processes. Then the accelerator added too soon, or you need dispersion of purity, especially in case of a nitrile rubber, dispersion of the solubility of sulfur is limited. Suppose, especially non-tire products are using the nitrile rubber, they either magnesium coated sulfur or the sulfur to be added at the beginning of the mixing cycle, or the too high rotor speed, the material added too high temperature, inadequate cooling compound, because in case of either the milling or the intermix or the bindery, there is a cooling arrangement is there. You have to consider The insufficient cooling also gives us some problem, whether it is a rotor cooling or the very clear chamber cooling. These are equally important, including the research door. Similarly, the cases of the mixing and intermix as well. Then the contamination, physical contamination, because in case of rubber, virgin compound, other than virgin compound, they are all foreign matter. Even the compound is over is a foreign matter. We have to be very, very clear. Most of the problem defect what you're getting in the mixing area may be the contamination of the leftover gases or the overage. Insufficient cleaning but then if you have the same equipment like intern is very used for future rubber or as well as the general purpose rubber, the mill cleaning is a very, very important. Other is there could be a contamination. Then the oil spill leakage, especially the what I consider about the oil what is using and what should be using, the lubrications in the Banbury should be the more or less same. So we can avoid the contamination of oil leakage, also giving the excessive oil, changing in the viscosity of the compounds. Then the poor handling in the dump mill, generally what is happening, incorrect roll temperature speed, too high loading, the clay fillers, generally poor dispersion, distribution, scotchy compound left on the mill too long. Is something what is happening, this may have the limited storage stability. With the over filling, sometimes it happens when you have if you do not have a number of mills set up or one or two mills set up with the compound is running there itself. Temperature is getting generated, compound may get a scotch. Then batch to batch variations. These are the common problem all of you are aware. There may be the variation in initial loading, temperatures, ramp pressure, cooling. Generally what happens before loading the chamber of the Banbury, generally minimum temperature to be maintained in the Banbury. If the chamber is very cold and except initially you get the loose carbon or the unmixed compound. So until unless minimum 110 to 120 centigrade chamber temperature is sufficient, then you add so that there will be adherence between the metal surface to the polymers. Otherwise, proper mixing will get. Variation in compounding ingredient, variation in the dump time, temperature, energy input, variation of milling time, and amount of the cross-blending mill. Then the root cause, if you look seeing the suppose inconsistent viscosity if you get, what you look for? Compound is either stiff or soft. Then the material reliability. Second is the process deviation. Third is the temperature control. Real-time viscosity monitoring and standard. Let me consider what is considering the raw natural rubber. If you get a different viscosity, RNR is raw natural rubber. You have to either the pre-mastication or the blending the different batches of the raw natural rubber to get a consistency in the viscosity. Similarly, suppose the poor filler dispersion of carbon dioxide silica. Then actually your physical properties, visible agglomerate compound surface. First is equipment setting, that incorrect rotor speed or ramp pressure in the internal mixture, or the moisture content, especially use of dump silica carbon black, this for the moisture content they are taking formation. Then order of ingredients, adding oil plasticizer too early, which lubricate and the filler instead of dispersing it. That's nothing, as much as possible do the dry mixing. Oil should be placed more or less whenever if you add the oil or certain antioxidants, you got a softening point low, they generally the slippage occurs between the metals and the rubber surfaces. So dispersion, inadequate sharing forces, the dispersion is poor. Similarly, adding of the oil or plasticizer as the sequences they added, then automatic weighing system and climate control in the filler storage is also equally important. Suppose if you get a scorching problem, premature vulcanization mixing area, lumps of the pure rubber found in the unmoored grain. There is a temperature management. Final stage of mixing temperature exceeding 5 degrees centigrade. Cooling in an inadequate patch of cooling system compares with high water temperatures, especially in the summer. Cross contamination, this amount of accelerator from the previous batches left, and the install high efficiency spray putting effect with the zero residue mixture cleaning protocol. If you have a surface blooming or porosity comes in the compound, white powder film, there's a bloom. That you know that the bloom is also it is a generally happen not if the exceed the solubility limit of a particular material in the polymer matrix. Generally, what is happening, either there is a bloom or there is a porosity. Now question is to look that what happening root cause that the chemical dosage exceed the solubility limit of the rubber. That means the compounder should know about the sulfur. Generally I told you general purpose rubber, generally we depending on the type of the rubber grains, generally about 1.5 to 2.5 normal conventional. Like a natural rubber, if you are using the 2.25 sulfur, when you replace 100% SBR about there is 23%, about 25%, 75% of the sulfur you must consider about 70 or 1.8 and so on. That's the way when you change the NR to SBR, sulfur acceleration has to be changed accordingly. And then then moisture trap, generally chemical dosage exceeding the solubility limit, because compounder must have a knowledge that these are the ingredients, what is the solubility limit in a particular polymer. As I told you, the solubility parameters of the ingredients and solubility parameters of the polymer is available. You see that they are very close, they are compatible. Simple example, I can tell you that butyl rubber generally with the paraffinic oil, maximum paraffinic oil. But paraffinic oil is better to compatibility, other is low job. But in case of natural rubber or the SBR, the naphthalene or the low pH oil, giving the better, they don't got the oozing out, no problem. But if you go for a polar rubber, then the ester type plasticizer or high aromatic content plasticizer is needed. And let me very clear all the generally the warming delay of processing, then insufficient maturation sometimes, because the natural rubber mix, as you know, the rubber molecule they are all in the motion, room temperature, high temperature motion is more. So suppose if the natural rubber, the chains are not grouped in a certain molecular weight, generally it is about 10 to the power 5 to 10 to the power 6, this range the molecular weight of natural rubber. And when you breaking down and etc., the molecular weight should come around 20,000 or 5,000 to 20,000 at the time of the cure. So if the nerve is not properly break down, you get the problem of, either the calendar sinkage or the dice or subsequent problem. So aging also same thing like that. The natural rubber mix, generally they require certain aging time. Synthetic rubber it will be reduced, but if you want to do that, the natural rubber is a pre-masticated and it's the same constant viscosity rubber, that time will be reduced drastically. Now suppose the corrective action require mixing is actually digitization, that is a transition to the artificial intelligence mixing software to auto-adjust cycle time based on the batch energy. Mostly SCADA and other people are using. And preventive maintenance, the calibration of the thermocouple or ramp pressure at a certain interval is required, because those data, if it is wrong, ultimately your decision will be wrong. Training of compound, as you know, the skilled manpower is required. Generally another thing also, you can do the generally treatment approach like the Six Sigma fault tree analysis or the failure mode analysis, the failure mode, either PFME or DFME, this type of things can be isolated these causes. Let us, regarding the qualities, considering next 10-15 minutes, I will talk. See, when you talked about the market trends, they want the cost and quality, the high quality of the low cost. Now, let me consider, when you say the quality, the definition is a performance by expectation, this must be greater than equal to 1. The market expectation increasing, if the performance is same, the quality is deteriorating. That means You have to continually improve in all the cases of the quality. Even a good formulation, if the quality consistency compound is not there, people generally adjust the compound. Instead of that, see the other parameters, the process parameters and so on. When you do the cost of the materials you purchase, generally you purchase the cost plus profited price. But today, the price minus cost is the profit. That means customer what the market is giving. The cost is very, very important. I will explain. The cost is not only the raw material cost. So questions today you have to look into. If you want to the bottom line, the organization, you have to consider what is the market price minus the cost. Now, what is the cost? Cost, it is the raw material or the purchase cost plus processing cost plus rejection cost. Total cost. Generally, we always go for the cheaper raw material. So when you approve the raw material, it costs us whether it should perform the way you want to do it. You just should meet the specifications. So purchase cost, any new vendors, new materials you select, new compounder, use a process cost, see that when you trial it more scraps and other, and the cost of rejection of the finished product. So final approval to be given considering that one, and not only the raw material cost. It is essential to consider the total cost as the input cost for the calculation of the product cost. Now actually, when you consider what is the cost of quality? Cost of quality is not done right at the first time. Non-adherence to the justified manufacturing activity. Now, when you consider the cost of quality, cost of good quality, and cost of poor quality, where is the cost of good quality? It is a prevention cost plus appraisal cost. Prevention cost means, the PPAP, PQP, FMEA, process capability, design manufacturing. These are all preventive education, training. All this is prevention cost. Review of the different processes. Appraisal cost is the incoming inspection, in-process inspection, final inspection. That means the testing, releasing. Raw material release, in-process release, finished product release. It's called the appraisal cost. But the cost of work or internal failure cost. There is a work which is not right in the 9 So releasing materials, it is not proper, it's not making the release. Internal failure cost you have to consider. Then the external failure cost when the product comes to return. So internal failure cost is to be done with the root cause analysis and the process delay, rework, reinspection, anything starting with R, the rework, retest, repair, reinspect, scrap, validation, the downtime, lost capacity. These are called internal failure costs. Then come external failure cost which is quite high. The question is external failure cost with the problem solving, corrective action. Here also problem solving, then preventive action to be taken. Now let me be very clear. Generally, the visible cost we look into the scrap, rework and warranty. But we never considering the conversion efficiency of the material, inadequate resource utilization. Sometimes you see some raw material suppliers, the mixing time and energy required increases. You get a scrap and etc. The conversion efficiency of the material, that is called the material balancing, is required. What is material input and what is the really the output of the product. So what is the losses we consider. Similarly, inadequate resource utilization, excessive use of material, over design, cost of redesign or reinspection, cost of resolving customer problem, lost customer and high inventory. These are called hidden costs. So the hidden cost of the Indian companies varies from, let us consider 5 to 20%, the direct profit. The world-class company, generally the cost of quality is less than 5%. When you go for a Six Sigma, the cost of quality, let me consider the world-class company, the cost of quality less than 10%. Now if you are working in Three Sigma, cost of quality is 20 to 30%. So to conclude that how to reduce the cost, one is the total cost to be reduced drastically. First you have to consider the external failure cost. That means not a single defective product should go into the market, whoever will be responsibility. That means more inspection is required. That has to bring down. When you do the external failure cost zero, then your internal failure cost will increase. The more testing, more retesting, reinspection, internal failure cost will increase. When the internal failure cost is down, your appraisal cost will increase. But ultimately, it is the prevention cost, that is the which I told. Prevention cost increasing is much better than the to reduce the total cost. Major role is the increase the prevention cost. But there is a threshold limit. Beyond that is not possible. So that means why you considering that if you improve the quality, very clear improvement. Quality improvement means you consider all the decreases, the cost decreases due to the less rework, fewer mistake, fewer accident, the productivity improves, increase in market share, improve profitability. Then sources available, you can go for R&D and new development and so on, investment. So this is called safety and quality chain reaction. Now let me very clear how to calculate the cost awareness inside the plant. Now question is, generally when you calculate the cost is the material cost, all the material used both directly, indirectly, labor cost and overhead. As I told you, profit, sales price minus work cost. So what is the role of technology? Is a compounder or the designer? All these roles. First is that their role is the increasing profit margin, meeting customer demand, increasing business potential, new market. How can be done? See, the first is the material flow. They must understand the raw material in store awaiting primary processing. That means delay in release, and they are waiting. More inventory, more cost. Then convert it to the work in progress, being processed or stock awaiting further processing. Then you get a finished product. Then product in store or awaiting delivery. That means through this process we get a direct cost of scrap and waste. Indirect cost is excessive inventory. This is reduced. If you do that one, what is the where we are cost losses? Now what is the role of compounder? The raw material specified. If the specification is wrong, when raw material specification you are considering, there is a specification control system we have to include. Wrong material use, product control system. Material over specified, sometimes we consider the cost will increase. So specification system. Stock waste, spillage, process scrap, waste scrap management. Inaccurate measurement control system. Because today, think most of them we online and offline detailed measurement we do. Mostly online measurement with sensor, low cost automation also help. So if you go for factory which is working with a different sensor to control that one, this cost will reduce drastically. So these are that actually the raw material part is the combination of the cost effective material, approved alternative, the material. This is the way the raw material or compounder should work, because material cost in the tire industry close to 60 to 65%. Non-tire industries come between the 45 to 50% organized sector. So the raw material, the cost effective material, the alternate material or the substituted material can reduce the cost of the company. So the process waste or the scrap problem, deterioration, indirect understocking, overstocking in the finished good. Now, if you look to that, this is a very important slide. Where do we are losing the factory? First and foremost, what are the losses? First is the raw material you get a rubber, carbon black, or the fabric and the beadwear. And the losses is the scrap, downgrade, all those. These are the losses. This is called 16 losses in the tire industry. Then green tire, pure tire, this is also scrap. This is losses. Energy, power, steam, ideal running, leakage, all those. This is also cost. Then you get a maintenance and the administration. This total cost, if you want to reduce, then we have to analyze this data and try to see that what best one can do. Now, question is, in summary, I can tell you quality. One is the quality. There are the different methods looked into: housekeeping and safety, very, very important into the 5S activities. Identification, traceability, visual management and visual control, especially the identification order black is very difficult if you do not identify it properly. Third is the FIFO, plant layout and planning, both with the storage, okay, non-okay material to be separately. Quality of utilized water, air, steam, I told you. Knowledge of cycle, that is the supplier input, process and output and customer, and consequence matrix using the 7-2C tools. Then continual improvement through PDC or SDCA, Plan Do Check Act or Standardized Do Check Act. Encourage quality circle, communication, visual management and visual control. Basically, the first 5 points is very, very important. Housekeeping, safety, identification, traceability, first in, first out, storing okay and non-okay material, and nothing should be on the floor in the tire industry or rubber industry. Anything in the floor, be it a compound, be it a liner, be it anything, that is the contamination ultimately product defective. If you consider the cost awareness at all level is required. People must know not the cost of the per kg of compound, cost of the raw materials. Little bit awareness, instead of percentage, in plant generally you consider percentage of scrap, instead of the rupees loss is more important. You know, this one tire scraps directly gets scrap potential about 25-30,000, in bias tire about 10 to 15,000. So this is the way the concept people must be aware of it. Waste elimination, man machine, that is the ideal running, excess people, all this. Cost optimization through quality function deployment, closely work with the suppliers and customers, optimize inventory, optimize recipe, cost-effective substitute material, reduce indirect material consumption, reduce cost of maintenance, improve energy utilization, reduce unfavorable variables, product what market needs, produce what product market needs. In general, why I am telling those who are compounder and other, they are also visiting the plant. It is very clear, a good compound become bad if all those things are not considering. So go on changing the new compound without changing the downstream processes, the downstream concept. None of the compound is going to work. Productivity, all you know that we and others, then the delivery and the safety. Let me ask you also, a few things last time can say, what should be the housekeeping? The compound identification, this is on the ideal plant. How this compound to be identified and stored in a lift truck. Similarly, the cases of the see that the lift truck storage area. Third is the how to the extruder area. This is the way if you want a good quality material, your compound should work properly. Now this is the stock preparation area. So let me be very clear what I would like to, I will give the maximum time for discussion. The mixing is definitely a blend of science and art. You can reduce the percentage of art by understanding the science. And the success depends on the knowledge, experience and time. Why considering the knowledge? Because the science behind it. Every root cause has a science behind it. We try to solve the problem without understanding the science behind it. Let me be very clear. If you see that most of the, I will give you a simple example. Why the knowledge is very important. Suppose some blooming comes on the surface, or some porosity comes and etc. We go for certainly without analyzing that. Let me very clear. If a porosity comes, you take the sample. If a bubble blisterosis comes, you cut it. And if the magnification that the surface is a dull, whether the surface is a shiny, whether the surface is a something is melted within a surround any material, undispersed material. You can say whether it is undispersed material, whether it is a air entrapment, whether it is a moisture entrapment, or it is solvent. So these are simple techniques is there to find out the root cause of the day-to-day process problem. Always we try to jump of the compounding, that is also not always true. Similarly, the cases of which there is a blooming. Now there's a lot of things are available in the material, as I told in the earlier slide also, how to identify the blooming. The question is, if you have a blooming, if you get yellowish in color, try to see the proper. First and foremost, whether it is acidic or basic. The basic material, the acidic material, dilute acid do the job. The acidic material were basic. First, you go the acidic and basic. Then, if you suppose if you got if you find that the certain yellow or white, and if the yellow continuous sulfur, one drop of carbon disulfide, and if you say that is a dissolved, and you try to see that, generally you get a ring type structure. So if it is a ring white, ring stearate, automatically you can easily find out the acid basic thing. Similarly, if you have a certain antioxidants and other brownish stain, you scratch it and do the PLC. So really the small laboratory, all these things is possible to understand the science. Suppose sometimes we found the concentration from product failure. Generally, when the product is pure and very difficult to identify the reason of failure, require a lot of the costly equipment for that, for the forensic analysis of such failure. my request to all of you who are attending, try to go to the basic chemistry and try to show them how small tests can identify the root cause of the problem. Mr. Giri.
Thank you very much, sir. We can session. You can you can close your presentation. Mr. Ajay, how to handle this question session?
So already the questions has been registered. So I will call out the questions, and if it is possible, that can. I also have shared already the questions in advance.
Okay, so you want to directly start from the question and answer session block?
Yes, we can do that.
Okay, so you can start, please. Sir, can we take questions now? And we have.
Yeah. Actually, some questions already received. First is there any calculation or formula detailing the maximum amount of sulfur that can be used in a polymer? Can be very clear.
Ajay, can you project all these questions on the screen and then answer it, so all can be see that?
Yes, we can do that.
Sir, Ajay will present the question on the screen, and then it will be better to do that, sir.
Yeah, please.
Can you see?
Yes, Ajay. Yeah. You can do the full screen slideshow.
Yes.
Yeah, in the mobile also I got it.
Yes, sir. These are the questions, sir.
Yeah. Is there any calculation or formula to determine the maximum amount of sulfur that can be used in a polymer? Very clear. Sulfur has got a limited solubility in the different polymers. As I told you, in the natural rubber itself, about that as 1 to 3 pHr is good, but beyond 5 pHr, if you want to add, you have to go for insoluble sulfur. Gel purpose rubber, generally all this, but if you go to the nitrile rubber, solubility is limited. You can generally 1.5, beyond that. Anywhere, suppose sulfur, if you want to be higher doses, then you have to consider the insoluble sulfur. The sulfur is used between rubber industry 1 to 3/3 pHr or maximum 5. But between 5 to 20 pHr, sulfur is a leathery stage in rubber vulcanization. Generally, after about pHr to 30 pHr, you get it. So that sulfur, if higher doses uses, so you not let me very clear there. The maximum torque is hardness is increased, so that is not usable. That's the reason one has to consider the solubility parameter to the type of the polymer you are selecting. First and foremost, sulfur as a cautionary ingredient for the unsaturated polymer. Generally, saturated polymer you don't use. Yes, we can use a polymer which is the main chain saturated, side chain unsaturated. We can use the sulfur. But in that cases also, since the number of unsaturation is less, automatically sulfur is to reduced and accelerator has to give you more. These are the thumb rules. I hope is clear. Second is it possible to design AI system for tire compounding aimed at helping beginners better understanding parameters such as MPA, tensile strength, kilometer? Yes. As I told my slides also, whatever your previous data available, I told you the first and foremost, the flowchart of the historical compound data is required, followed by the data cleaning and normalization. That generally a compounding expert, you have to take a sum from IT expert. Then you have to give your input like your materials, what is the pHR using different ingredients, and out of the ingredients, the polymer behaviors and the polymer certain characteristics. If you're using solution SBR, functional SBR, so on. If the carbon black, that their surface area, particle size, the curing, that all is certain data, slow accelerator, medium, fast accelerator, and so on. Then you have a certain training is required with the IT. Then you have to call for a validation. Then your performance prediction optimization. This is possible, but how many data you are able to input? Then actually, why do rubber tubes used for domestic gas cylinder connection now have a strong metal reinforcement? How is it done? That is very clear. Earlier, these gas cylinder tubes are based on the natural rubber or the general purpose rubber. Then they came out the nitrile PVC blends and polychlorine rubber. But what is actually happening, if you know the gas tubing, when the gas cylinder, they considering the cylinder knob that is expanded. Now since the rubber is under stage, whether the gas tube or the gas cylinder, generally ozone crack, weather cracks appear. So they convert it into the polychlorine nitrile PVC. But ultimately what happened, this is also did not work well. So the Indian standard or the BIS, the specification, that should be reinforcement so that the stress on the rubber part in the knob area will be much less. So even there is a crack, it's a type of hose type. You have a inner tube. The inner tube generally they put nitrile PVC or the oil resistance polymers, and outer tube weather resistance, and then basically either nitrile PVC or the rubber, and then braided hose type. Then you have inner liner, braided hose, and then you have a cover. So that's the way, exactly the way the host they manufacturing, they do that. Then fourth question, is it possible for crumb rubber used in bitumen to be completely recycled, and what process is involved? Nowadays what is happening, the crumb rubber with the bitumen and surface modified, crumb rubber mixed with the bitumen used for the road surface. Now, when the bitumen and crumb rubber road surface is there, to separate is a challenging job, because as you know that today, end of the life of the tire, they do the pyrolysis. Similarly, here again, which is, if you do not in a incinerator or the closed chamber, the environmental, not the environmental friendly. So that you cannot, only burning means what is happening. Again, if you have the incinerator, the closed chamber, if you do that, whatever there's a fume, pyrolysis, what they do, generally when they give the tire in chips there itself, the closed chamber, when you do that, ultimately all of the rubber and the mixed compound, they convert into the oil, and you get a filler carbon black, and you get a steel black or another. Even the fabrics and other, everything is decomposed. And those liquid are generally transferred, which is about the tire pyrolyzed oil. Similarly, you get a filler, about tire pyrolyzed, you get a 50%, filler is get about 30%, if the steel tire got about 15%, remaining 5%. This is the way the tire pyrolysis do. Suppose if the bitumen coated crumb, if you road surface you collect, you have to also more or less same process you have to do. What is the quantity of accelerator we have used in high dyne rubber like NR? It is very clear, depending on the NR, you have a conventional system. Generally, sulfur we use about 2 to 2.5, Accelerator generally use about, let us consider, depending on the accelerator, 0.6 to the 0.8, the maximum one, if it is the sulfonamide accelerator. If you have a not the sulfonamide accelerator, in such cases, if you are not there, you can use, especially footwear and other, they are using the MDT, MDTS, or the sulfonamide plus DPG for the passenger radiator, depending on. The sulfur, generally, if you have a conventional, about 2 to 2.5 pHr. If it is MEP system, 1.5 pHr. If it is EB system, about 0.5 pHr and more accelerator. What is the application of an accelerator? Application of accelerator is the generally accelerate the curing reaction. You can cure also sulfur, but it takes a number of hours, but which is not feasible as a productivity point of view. What are the functional group? Functionalized SSBR. Now, this is a very important question. Functionalized group in SSBR either hydroxide or the carboxyl, the COH, or the amine, or the ether, or the silane, or what is the function of the, in case of a rubber, when it's cured, you get a different type of crossing. You get a monosulfide, disulfide, and you get a polysulfide. But there you get also pendant sulfur or accelerator sulfur. And you get a certain end change. Generally, normally, it will have come due to the free end change, generally, besides this crossing. Now, what is happening when you go for polymer filler interaction to enhance? In such cases, you require the no polymer chain ends available. So what they are doing, the polymer chain, they are functionalized with this group. This functional group, especially for silica, take a polymer filler interaction. As I told you, whether it's a tire compound or non-tire compound, normally, if you have a neither the control the frictional heat generation, which is how the heat will take it out. Either the flow rate of the water, and also you have to consider what is the heat generation, what is the amount of heat you want to take out. It is a mass specifically delta T. So then the volumetric flow rate of water is more important, quality of water is more important, scaling to be cleaning at a certain frequency to cooling system to be effective for any rubber equipment, whether it's extruder or a calendar or a mixture or a mill. What impact does this have to viscoelastic property? Generally, the high heat generation, if the temperature generation is increasing, what is actually happening? You get your residual viscosity will reduce. Ultimately, what I want to say is it is not advisable at all. The viscosity will affect subsequent process which happen not times. Next question is, why do TBR lab pattern require 100% natural rubber in the TBR? Let me be very clear. The actual natural rubber is a very, especially overload region. Natural rubber has got a high molecular weight. They have a high load bearing capacity, and that's the reason. And the natural rubber is used predominantly for TBR. 100% SBR, and the SBR we are going to use in passenger car. High speed abrasion is required there itself. Okay, how does using, but nowadays is the new requirement, if you are maybe certain people are used to the partly replacement of certain synthetic rubber as well. How does using low particle size reinforcement? See, actually, if you see the reinforcement, what the surface area and particle size, they are interrelated. Lower the particle size, higher the surface area, better will be the reinforcement. That is the basic, that's the reason called the active zinc oxide. You can reduce the doses of the same modulus. There is a bifurcation level, stable material reacting. What does exactly does this mean? Because in case of a, let me be very clear, in the rubber compounds, the slide which has shown the stable and the reactive. Reactive means which is happening, the silica silent coupling agent. They are reacting together selenization. So there is a reactive material. Some of the antioxidants, suppose if you use the 650 gives low softening point, certain antioxidants, the softening point is more than the less than the down temperature. Some of the things they melt. That is the reason TMQ is a polymerized. They are making, they are about 100 plus degrees. They are melting point 100 to 110 degrees centigrade. But in case of a 650, some of the antioxidant losses, not the full deep. So the reactive material, what are the fumes they are getting in the mixing area, curing area, that means what is actually happening? The sulfur, they react, it may base to as nitrogen dioxide. Similarly, the silent coupling agent, part of the accelerators, activators, zinc oxide, the complex that wing. So these are called reactive material. But the zinc oxide, what is happening? Certain zinc oxide is available for this. With the polymer, carbon black, zinc oxide, these are the all called the stable material. Stable material means using the rubber product using those materials still exist there itself in the different form. When the wear and tear taking place, this material goes from partly to the environment and partly to the underground water. Yes, actually, number 13 question, the AIML rubber compounding, that sounds quite interesting. Yes, it is interesting means, but here only thing is what is your historical data. First is the data cleaning, data acquisition, and the data cleaning is a major job. So most of the industry people are working, and I hope this is the future, maybe not today, maybe 5 to 10 years down the line, possible. What can be the advisable tolerance limit for setting specification of rear property? Let me be very clear, the rear property tolerance limit, see the question is depending on the type of the compounds and other, you have to consider, let me all of you aware of it, why the temperature we call 140, 160 degree Reo, or why the Muni we do 100 degree, why we do certain polymer, and which has got a certain relevance. When you do 100 degree Muni viscosity, some of the little very clear, the processing temperatures is very, very important. Now suppose in rheometer, generally the flow time is, you are curing the product 140 degree centigrade, curing the 160 degree. But what is happening, the time longer we do. So we do high temperature 190 degrees centigrade to see that. So we have to generate the data correlation between low temperature zero and high temperature zero and see that what is the equipment available, what is the extrusion temperature coming out. Let us consider 110 plus minus 10 degrees centigrade. Calendar temperature is 80 plus minus 5 degrees centigrade. So all these temperatures range, what is the residual safety left behind, so that accordingly you can make the specific. You have all this equipment, you have thousands of data available. You try to see those data and correlate with the product performance, and accordingly you can adjust them. Is there any thorough study in the mechanism of volcanism, the effect of failures, volcanism process? Yes. There are a lot of studies there in my thesis that we have done high temperature volcanism blastomas on the 75 80s. A lot of data is available, a lot of papers published in rubber chemistry and technology. You can go through that. RCT, there is a complete review. Several reviews has come about this.
Any more question, Ajay? Or
sir, we got a few more questions.
You can display directly on the screen.
Those questions are just received now, sir. So the question is, I will just follow out. The tire manufacturers are claiming more than 70% of the sustainable materials in green tire production. Will it have more biodegradability index in comparison to the conventional tires after the end of life?
Let me be very clear. Today, there is a debate which is a sustainable material. Today, the ISO has not defined which is sustainable material, which is not sustainable material. So far, natural rubber, yes. Silica from rice, yes. Bio oil, yes. Anything biosource. And now, remaining material, let me be very clear. If you are using the natural rubber, sustainability is clear cut. What would like to hear that when you consider 70 or 80%, 90% sustainable material, what is the source? That means you have a natural rubber, you have a synthetic rubber from biosource, you have a silica from rice husk, you have a polyester, because recycled polyester, you have eco oil, eco-friendly oil, you have regenerated carbon black, or you have a recycled material. You have steel tire cord with certain recycled material input, and a similar. These are the way they have to calculate, and this calculation methodology is done by the ISCC. For India, is ISCC certification. But yes, tomorrow I have not shown the slide. The sustainability material content in the rubber product will come to the picture. Now, today, the method available but too costly. Like we do the NMR for the pH content on the rubber product. So the method is here, but the stages. But until unless the ISO define the sustainable material definition, whatever people are claiming and etc. as per the ISCC. And that is material that you are getting from the biosource. Sometimes in near future, biomass, maybe the lignin from the paper waste. These are the materials will come as the input. Even the carbon black they are trying from biomass. So there carbon black, there is a concept about the methane cracking and so on, the lithophone technology, monolith technology. So the people are trying, but the problem until and unless quality of material, quantity available, very difficult. But yes, biodegradable material if you use in this silicon. Rubber itself, natural rubber is not biodegradable. What we are considering, since the natural rubber itself, the plant is acts as a carbon dioxide sink. Sustainability definition is the economic greenhouse gas sink. That's the really natural rubber is sustainability. Natural rubber is not biodegradable. Point has to be very clear. Any polymer with high molecular weight, very difficult to calculate. How many times a recycle view so that the material input would be reduced. Okay. Any other?
So the next question is whether the low fast transmission temperature TG compound is going to give the better abrasion properties always.
Let me be very clear, polymer is one part, it is about 45 to 55%, 50 plus minus 5%. Other ingredients also plays a role. Yes, overall TG you have to do, not the polymer TG. Yes, suppose if you take the polybutadiene, TG is about minus 90 degrees. But this is 100% polybutadiene you cannot use because the right handling and other characteristics is concerned.
এগুলো কোশ্চেন এখনো করতেছে, সেগুলো ওরা পড়ে পড়ে শোনাচ্ছে, উনি আবার ওটা অ্যান্সার দিচ্ছে। শেখানোর কিছু নেই। অপশনে নেই কি করে।
The important green chemicals required for dairy industry, on which chemical industry should put an R&D.
কমেন্টস করতেছে তার সেই কোশ্চেনগুলো ওনাকে বলতেছে, পড়ে পড়ে শোনাচ্ছে।
That the TNQ from the green aniline. So that itself, if your product, your input is from the green source, automatically you are going. But rubber chemical manufacturer, they are trying to do that. And let us see, but ultimately the lignin is a candidate for the rubber chemicals manufacturing. A lot of research are going on across the world.
What are the causes which can be for blue color blooming issue in compounding?
Let me, it is the oil. Let me very clear type of the oil you are using. Generally, if it is not compatible with your, if you are getting this blue color. Basically, the oil is one of the responsible. Yes.
Is there any scope of electrical conductivity studies on passenger car tires? Is it really relevant?
Yes, you can do that. See, today they have the state compounded. The problem is that is the reasons the static electricity is generated that has to be discharged and by the proper trade design so that this possible and that product is available in the market. Yes. Next.
There's a relation between the porosity of silica and the polymer silica interaction.
Porosity of silica and
the question. The question is not put up properly, sir. Actually, they are asking about the polymer silica interaction and effect.
Yeah, I told you, as I told you, if you looked into the polymer structures, as I have not shown the slide in the cross-linking, beside the unsaturation part, cross-linking, some of the unsaturation part left behind, some of the polymer chains, is not cross-linked. That is called the chain ends. Now these chain ends, they are flexible. So number of chain ends, properly polymer pillar interaction enhanced because silica is the pillar interaction. Polymer interaction, they give the different functional group. These functional group interact through the silent silica so that number of cross-link, the polymer pillar interaction enhances. This I told you earlier question also.
Considering the wide application, is there any requirement for change in compound design for EV vehicles?
Let me very clear, the EV vehicles always, whether it is OTR or two three-wheelers and extra, certain things are common. But depending on the, the fuel efficiency requirement, what the vehicle wants. Only thing is the weight, and as you know, waste, there is a chipping, chunking, cut resistance, these are the things available, more species, all those things are there. Yes, the overall species we can able to reduce, that will be much better for the durability of the product itself.
Any other polymer other than butyl rubber for inner liner applications?
It is halobutyl, these things, and also let us consider people are utilizing that cannot be utilized. The high acronyl content nitrile rubber has also be considering, but in case of a and the compatibility of the different components, that's why butyl rubber is used, but now the halobutyl, especially the homobutyl, is very prominent because there is a better compatibility with the peripheral components.
Your insight on devulcanization process.
Devulcanization is very clear. There is a difference between reclaiming and devulcanization. Devulcanism, what they do, when the crossing is there, you have a molecular chain, I told you 5,000 to 20,000 molecular weight, especially for natural rubber or the synthetic rubber as well. There is a sulfur cross-link, and what is happening without, when you do reclaiming or other process, what we do, we are breaking the sulfur as well as the polymer chain, so that we do not get that molecule. In devulcanization, generally, you break the sulfur, which is a mechanochemical. So that by certain chemicals they take the sulfur cut, keeping the molecular weight more or less same. That is the reason, so the devulcanism is much better than the reclaimer.
Another question, the PRI and PO values of the natural rubber are different from company to company. Is there any internationally accepted standard?
Depending on that, a certain standard one has to look into their processing. So many times I told you, raw material specification, generally all raw material suppliers, they get the specification from tire industry. Tire industry, what they found is suitable for their process, they give the specification. There are ISO standard for some other materials, there are people, but people they standardize as per their requirement.
Okay. I think we are done with most of the questions. Few of the questions are very similar in nature. One more question, sir. What is the trade-off of the acceptable level of resins in tires?
Depending on the type of the resin, depending on the type of the performance required.
Okay.
It's a compatibility, okay?
Right. I think, sir.
Thank you very much, sir, for your excellent presentation, and thank you everybody for attending this program. I hope that the session was very meaningful and there was a lot of learning. There will be a feedback form will pop up into your browser after as soon as you will exit this webinar. So please take a couple of minutes. It will not take more than a minute time to fill the submit feedback form. So please request all attendees to fill the feedback form. And we also thanks our title sponsor Ravi Shoni Group for sponsoring this program, and our co-sponsor sponsor AP Industries Limited for their participation. And helping us in organizing this program. Thank you very much, Mr. Vasudeva. If you want to speak a couple of minutes for the closing session, then we can stop this.
Thank you, Mr. Giri. I think we should thank our Chairman Emeritus for a fantastic program and presentations today, and very educative for me. And I don't know about the others. We have to collect the feedback. And excellent program, sir. Thank you very much. Coming to next, my duty also to thank our main sponsor, title sponsor Ravi Shoni Group of Company, and co-sponsor AP Rubber Industries from Haridwar and Oman. They are our backbone of the program, support us behind the program. I thank once again, and I requested the people to come front to sponsor such programs in future also. Mr. Vitesh Giri is doing a wonderful job in IRI, and he is every month catching up on eminent speaker, and he will be continuously doing this IRI Insight webinar every month, one program, and please wait for his next program. And I also request people to come forward to sponsor this program. Thank you very much.
I request all the people who have joined to follow our LinkedIn page on IRI page on LinkedIn to get updated about the upcoming programs, that is future programs and events and organizations. And a special thanks to Ajay for have a nice
Yes.
coordination of the
Yeah, Ajay.
session.
Thank you.
Thank you, and all of you can
Yeah,
log out.
Mr.
And
Mr.
thank you very much,
Mr. Giri,
again
Mr.
for the
Mr. Giri, a last word. Member must request to take the membership IRI. Those who are not member of IRI, please take the membership IRI going to the IRI website. That also, Giri, I suggest the link of IRI website, the lecture you just put somewhere else.
And in future, in the bottom line, we can put the website also.
Last announcement that lot of people have expressed their desire to contribute to the IRI. So we will contact you, all of you, separately through email about how you can make a contribution to IRI, either experiencing or either sharing your experience or monetary, whatever it is. We will contact you separately for those who have wished to contribute to the IRI cause. Thank you, and with this note, I am closing this webinar and request all of you to please fill up the form. Thank you.
Thank you, Giri. Thank you, Dr.
All of you can exit.
Thank you very much. Very nicely organized. Thank you.
Thank you.
Yes. Meeting close.
All can exit, leave the session, and then I will close it. You can also close WhatsApp.
Meeting close.
Sir, you can also leave the session.
Thank you.
Sir. Thank you, sir.
Thank you.
আচ্ছা ওটা তার লাইভ চপ করে দিন